Okay, everyone. In the previous video, we talked about ions, which is where elements gain or lose electrons in order to end up with a charge. And the reason that they do that is because they want to achieve a full valence shell, making them stable. So the example that I gave you, so we worked on lithium, and we said that lithium in its ionic state has a +1 charge. We worked with carbon, which we said had a -2 charge. And same thing applies if you worked with calcium, that has a +2 charge. If you worked with, let's see, let me give you another one. Fluoride. Fluoride has a -1 charge, and that's all determined using whether they gain or lose an electron. So these are all ions. The positive ones are called cations. The negative ones are called anions. We are going to now talk about ionic bonding. This is a reaction because carbon and fluoride, we said that carbon needs to gain 2. Fluoride needs to gain 1. Okay? Well, where do they get them from? Where can carbon get those 2 electrons? Where can fluorine get that 1 electron? That is now using ionic bonding. What that is referring to is a reaction between a metal and a non-metal. This is very, very important to remember. Ionic bonding only occurs between a metal and a non-metal. It is also an attraction between a positive and a negative ion. Remember, positive and negative attract in the case here in science. So, let us consider lithium and fluoride. So, lithium has a +1 charge in its ideal state, which means that lithium, in order to get that +1 charge, wants to lose an electron. Fluorine, if it wants to achieve its ideal state, has a -1 charge, which means fluorine would like to gain an electron. Look, it's a match made in heaven. Lithium wants to lose an electron. Fluorine wants to gain an electron. So they pair up. Lithium will give fluorine that electron that it wants. So lithium will then end up with +1. Fluorine ends up with -1. They are attracted to each other, and we end up with a compound called lithium fluoride. And we're going to talk about naming later. So this is the compound that forms through ionic bonding. And we call this an ionic compound. Okay, it is called an ionic compound. It is between a metal and a non-metal. Lithium is a metal. Fluorine is a non-metal. A lot of people mess up with this, so I cannot stress it enough that an ionic compound is only formed between a metal and a non-metal. So to determine that, please make sure that when you look at the elements in a compound, if it is a metal and a non-metal, then great, it is an ionic compound. We will talk about the situation where we may have 2 non-metals, but for now, a metal and a non-metal together form an ionic compound. Let us look at a little bit trickier case of ionic bonding. Let us look at calcium, which is a metal. Okay, so these are metals. These are nonmetals. So, let us look at the case of calcium and fluorine. If we were to mix calcium and fluorine together, to achieve its ideal state, calcium, which has 2 valence electrons, we have fluorine with 1. Oh, actually, sorry. No. Fluorine has 7. My mistake. Calcium would like to give up 2. Remember, it can either have a choice of giving up 2 or gaining 6. I'd rather give up 2. Fluorine, in order to achieve its ideal state of a full valence shell, would like to gain 1 electron, which is right there. There's a missing electron right there. So if calcium wants to lose 2 electrons, a fluorine atom would like to gain 1 electron. In order for these two to come together and form an ionic compound, do you think it can happen only in a 1-to-1 ratio? Well, calcium wants to lose 2. The fluorine only wants 1. So how many fluorine atoms do you think we need in order for calcium to be happy? Well, that means that calcium is going to need another fluorine atom to be available. So let me try to color code this to make it a little easier. Here are calcium's valence electrons. So let me make calcium's valence electrons red. Okay. So what's going to happen is calcium is going to give fluorine, or one of the fluorine atoms, its valence electron, and it's going to give the other fluorine atom its valence electron. That's the only way calcium can lose both of them. It needs people or atoms to give it to. So calcium will give one of its valence electrons to this fluorine atom. It will take its other valence electron and give it to this fluorine atom. Now what we're going to end up with is a calcium ion. Remember? It's a calcium ion. So you're going to end up with, I'll put it here on the side, you're going to end up with Ca2+, because it's going to lose 2 electrons. You're going to end up with 2 negatively charged fluorine ions, which are called fluoride, but we'll talk more about the naming later. So we're going to have 1 calcium atom needs to react with 2 fluorine atoms in order that everybody is happy. Calcium gets its full valence shell, and each fluorine atom will get its valence shell. And in this case, they will form an ionic compound, and we will refer to that ionic compound as CaF2. But don't worry about this part right now. We will talk about how to write compounds later on, but it's important to know that calcium needs to react with 2 fluorine atoms in order that calcium and fluorine achieve their ideal state.